Welcome to another video on digital electronics. In this video, we will be seeing what is state equivalence and minimization. So state equivalence means we have to check which two states are exactly similar. Means having same inputs, I am moving to the same next state having same output, right? So if I have A and B, two states, when I give one to both of them, they both move to C and the output is 0, which means A and B are exactly similar. They are equivalent state, and hence I need not have both the states in my state diagram. I can replace any one state. I can replace either A by B or B by A, and hence what I will achieve by doing this is I will achieve minimization of the state diagram, and analysis becomes simpler. So two states are said to be equivalent if each input condition they give exactly same output and go to the same next state. In a state table, when the two states are found to be equivalent, one of them is eliminated without altering the input output relationship. This process is referred to as state reduction, right? So let's take an example here. I have present state, I have next state, and I have output. So this is my state table, right? Present state is A. When I give input as 0, I move to C and my output is 0 for that. Similarly, if my present state is A, my input is 1, I go to B and my output is 0 for that. I hope this is understood by now. How will I draw this first one? I'm having A, I'm moving to C, my input is 0 and my output is also 0. Okay, now what we have to find? We have to find which are exactly same state. So what you have to do is from here to here, you have to check which rows are exactly similar. So let's find out which rows are exactly similar. So check this row, E and G are exactly similar. F, A, 0, 1, 0, 1. We have to check from this part to this part. Should be exactly same. Which means what? Which means I can replace E by G or G by E anyhow, right? So what I'll do is I'll replace G by E. So let's do that. I'm replacing G by E, which means this state will go away completely. I will no more have G state. Along with this, you have to check in the table wherever you have G, you have to replace that by E. I think that's it. And this state will completely vanish away. There is no more G available. Wherever there is G, I have replaced by E. It is suggested that you redraw this table with the new replaced values. So due to time constraint, I am doing it in a single table, but it is suggested that you redraw this table again. After doing this, I have to reiterate the same step. Now again I have to check which two states are exactly similar. But now my G is replaced by E, so I have to consider E everywhere, right? So let's check what other states are similar. I can see D and F are similar now. The one in the pinks. See, I have E here, I have a E here, I have an F here, I have an F here. 1 0 1 0, which means I can replace my D by F or my F by D. So let's replace my D by F. So D will go away, which means this entire line will vanish. Entire line will vanish away, and wherever there is D, I will replace it by F. So I will replace this by F, replace this by F, and then there is no other D. Okay, again I will reiterate. Second step is over. I have to remove two states which were similar. I will again reiterate and check if anything is similar. Can you see something like CB00 anywhere else? No. FC00, no. EF11, no. FA01, no. EF10. See, many will say this is EF, this is also EF, but check this. This is 1 1 and this is 1 0. So it is not similar. And these states are anyways gone away. So I need not bother about these two states. So this is my reduced state table. From this I have to now draw a reduced state diagram. So how many states we are having? A, B, C, E and F. So I have A, B, C, E and F. Now you just have to check at input what is the corresponding next state and what is the corresponding output. And you have to draw this state diagram. So I suggest you try it on your own to check whether your state diagram matches with this state diagram. I hope the concept of minimization and equivalence is clear. I will stop the video here. Thank you for watching.